Okay, for this next set of problems, we're actually going to use this unit circle diagram. Now, these aren't just random values that are given to you now on this problem. They are specific to pi over 6. Pi over 6 is equivalent to 30 degrees. So let me just give you a brief little explanation of why these coordinates are what they are. It actually relates back to your 30, 60, 90 triangle. You don't have to write this part down, just watch so you understand where it came from. Okay, so the 30, 60, 90 relationship always has this relationship where it's one small leg across from the small angle, and then the hypotenuse is 2 or double that, and then this is square root of 3. So if we were to find the sine of 30 degrees using sohcahtoa, or y over r, it would be 1/2. Okay, and that's the y value right there. If I were to find cosine, it's going to be adjacent over hypotenuse. So anyways, you don't have to have a full understanding of what I just talked about. I'm just trying to make sure you understand that these coordinates are there for a reason based on geometric principles. And anytime it's a 30 degree or pi over 6 angle, we're going to use that for x and that for y on the unit circle. Okay. So again, the diagram did say it's the unit circle, so we can assume the radius is 1. And they give us the coordinates. So it's a lot like the last problem, but now we're going to use values that are real. We can count on every time. Every time we have a 45 degree angle, these values will be counted on for x and y. Okay, there's a science to it. All right, so here we go. Let me show you how we use this. This diagram will be given to you on your assessments, on your next quiz. Just have to know how to use it. Find the point xy on the unit circle that corresponds to the real number t, 3 pi over 4. Evaluate the 6 trig functions at the real number. Okay, so the first thing is we have to know how to draw angles. Should have mastered that in section 4.1. So where's 3 pi over 4? They even labeled the darn thing for you, so even if you forgot how to draw it. Okay, they don't have the negative angles drawn though for you. So we got to imagine an angle that's starting here. It's rotating around to 3 pi over 4, and the terminal side is right here, right? If I were to draw the angle, you don't have to do this every time. I'm just kind of making sure you understand the big picture. All right. So do I have a point on the terminal side? Yes, I do. This is my x, this is my y, and that's my r, just like the previous page. And now I can go ahead and find the 6 trig functions. Okay, so sine of angle t. Now I guess for short, since they put t as 3 pi over 4, you could just put t, but you could also write sine of 3 pi over 4 right here. Equals what? Well, it's y over r. So what's our y value? It's right here. It's square root of 2 over 2. So square root of 2 over 2. Now, do you need to show the over 1? Probably not. I think you guys got that figured out by now. There's the sine of angle t. Okay? The cosecant of angle t, I'm going to put the reciprocals right next to each other if I can. Just kind of split it here. So CSCT is the reciprocal of that, or r over y. So now it's 2 over the square root of 2, which needs to be rationalized to get the final answer. So I get 2 square root of 2 up top. The bottom I get 2, so look, this one does reduce. These 2's reduce out, and we just get square root of 2. So let me just clean this up. Cosecant of t is square root of 2. Okay? All right, so you try cosine now. I got this going for you. You try cosine of t and secant of t, and then try tangent of t. You might need to do the work for some of these up here. I don't know. It might get kind of crowded. So you try those last 4. Okay, here's your feedback on this. Cosine's x over r, so the x value is negative. So there it is. Cosine is negative square root of 2 over 2. So the math is very similar, right? We flip it over. So you don't even need to show the work, really. You should just know it's going to be square root of 2 and negative. But if you work through it, fine. Tangent is y over x. So looks like this to begin. But these are the same numbers, right? One's just positive, one's negative. You don't need to get too cute with this. These just divide out and give you 1. But it's negative. The reciprocal of negative 1 is negative 1. Okay, we're going to do one more here, number 5. Let's do the same format. I'm going to get us started for you to make sure you can locate the angle, and then I'll let you wrap it up. Okay, so now the angle's negative, so this isn't going to be, these are only labeled for positive angles. So for example, if the angle said negative pi over 6, it should be right here. Okay, down 30. Up 30 is there, down 30 degrees is this way. But it's labeled 11 pi over 6 because that's the positive version. All right, so you got to make sure you can find this, and you can even change it to degrees if you want to. If you want to take negative 2 pi over 3 and quickly convert it to degrees to help you with that, then go ahead. Maybe you want to write it down here. 180 over pi, so those reduce out and ends up giving me negative 120 degrees. So can we find negative 120 degrees on here? I hope so from section 4.1. So it starts here, rotates this way. There's negative 90. I need 30 more degrees. It must be this one right here. So here's my terminal side of this one. So there's my x, there's my y, radius of 1. And the problem starts over with those values. Okay? So once again, you could put sine of angle negative 2 pi over 3, or we could just say sine of t. Maybe you want to write the coordinate there so you're very clear. Here's our coordinate, right? Negative 1/2, negative square root 3 over 2 is what we just grabbed from the diagram. Okay? Radius of 1. Now we're just following definitions and doing the math. Okay? So sine of angle t will be equal to y over r. Okay? Cosecant angle t will be the reciprocal of that, multiplied by square root of 3 over 3, and we get this. Okay, 2/3 is reduced, so that's it. Okay, go ahead and pause, try the next 4, get those solutions to wrap up today's lesson. All right, so here's your feedback. Cosine x over r. So we're grabbing this negative 1/2 divided by 1. Secant, that's easy. Tangent, we got negative divided by negative, so it'll be positive. So flip it over, 2's cross reduce. That's what we get. And there's your cotangent. Square root 3 over 3. Okay, so when you're working your assignment today, if they give you coordinates like number 5 and 7, you're good to go. You don't need this diagram. But then when you get down to 13, they do say, using the unit circle, where they're giving you these values from the unit circle, these angles, you're going to want to use this as a resource. Have it open, okay, because it's not on that page. Okay, we'll stop there.